In this video, I want to go back to the generic class and look at type declarations again. First, I want to create an interface called queryItem. I'll put that in dev.lpa.util. This will have one method that, when implemented, will let us match an instance by one of its field values. The method returns a Boolean, is named matchFieldValue, and has two string parameters. Next, I'll create a new class, which will also be in dev.lpa.util, called queryList. This will allow users to query or search a list looking for matches when they specify a field and a value in that field. For example, if I want to get a list of all students taking the Java course, I can pass course as the field to use and pass Java as the value to match on. In this class, I want to include a type parameter that extends the interface I just created. I'll add a field, the list of that type, private list of T items. I'll generate a constructor using items as the argument. I also want to add a method that will take a field name and a value and attempt to find a match in the list. Public list of type T, get matches with two parameters, string field and string value. I'll set up a local variable, list of T called matches equal to new, array list diamond operator. Loop through all items. Check if there is a match on field and value. If there is, add the item to matches. Finally, return matches. This method sets up a new list of type T. It loops through the current items and then leverages the method on the interface. This means it expects any item to have the matchFieldValue method implemented. I need to go to my student class and have it implement the queryItem interface. I'll change the generated code to use a switch expression to check each field name that I want to be searchable. String fname and assign to fieldname.to uppercase. Return switch fname. Default switch expression arrow set to false. So far in this code, all I'm doing is making the field name uppercase. The field name gets passed as the first argument. I'll return false as a default, meaning right now it wouldn't match on anything because the code isn't checking any fields. I'll correct that by adding the field names and what a match is, returning a Boolean based on that condition. Case literal string name in uppercase, switch expression arrow, and that will return name.equals ignore case for value. This means a match is found if the name field is equal to the value, ignoring case. Same as above, but for course. Case literal string year started in uppercase, switch expression arrow, year started equals integer.parseInt using value. Returns true if the year started field is equal to what was passed in the value parameter. This code lets me filter my student list by checking any field. I'll add a call to this method in the main method. var queryList equals new queryList diamond operator, and I'll pass my list of LPA students. var matches equals queryList.getMatches. I want to match on course and Python, and print out the matches I get back. In this code, I want you to notice how I'm creating my list here. First, I'm using var, which means the type should be inferred, and then I'm assigning it a new instance of my queryList class. But notice I don't specify a type argument on either side of the assignment operator. I pass the list of LPA students to the constructor though, and that's enough information for Java to infer that this class is of type LPA student. I can confirm that by hovering over the queryList variable. If nothing shows up, you may have to double-click the variable name and then Control-Q. I'll do that. IntelliJ shows me that I have a query list of LPA student. Next, I execute the getMatches method, which will try to match students taking the Python course. Finally, I print out the results with my print more lists method from before. Let's run the code and see what it produces. You can see that it matched on all the students in my list taking the Python course. Your results will be different because of the random nature of creating the students. So that's kind of fun, but what if I want to use this functionality without using the queryList class itself? Let's say I just want this functionality for any list implementation. Going back to queryList, I'm going to copy the getMatches method and paste it right above. I want this to be static and include a parameter for any list to be passed, items, as the first parameter, which will be a list. Notice that T is underlined in all cases. Hovering over that, IntelliJ gives me the information dev.lpa.util.querylist.this cannot be referenced by a static context. What does that mean? Well, it means that the class's type parameter can't be used for a static method. The generic class's type parameter only has meaning for an instance, and therefore for an instance method. At the class level, this is unknown. When the generic class is loaded into memory, it's not loaded with any type parameter, so you can't use it in a static method, which is what I'm really trying to do here. But I can make this a generic method, which I covered in the previous video. I'll now add a type parameter, which goes right before the return type, the list of the type being returned, but I still have to make an upper bound for this. That extends the query item, so I'll do that. Okay, so what does this really mean again? In this case, what this actually means is that this t-type parameter is a totally different type, completely separate from the type parameter declared for the class itself. In fact, this type either gets specified or inferred when you invoke this static method on the class. Let me go back to the main method and now call this static method so you can see what I mean. var students 2021 equals querylist.getMatches, passing students the string literal year started and 2021, and print out the list. I'm calling the static method getMatches, passing it my list of students, but not the LPA students this time. I want to match students who enrolled in 2021. Let me run that. And you can see my list there. Again, yours will be different, but you see I've filtered the list to only the students who started in 2021. Now I want you to notice a few things. Firstly, students 2021 is inferred to be a list of student, and that's because of the argument I'm passing, which is a list of type student. But let's just see what happens if I'm vaguer. This static method always returns a list, although it might be empty if there are no elements that match. To demonstrate my point, I'm going to pass it an empty array list instead of a list already typed with a student. So what is this really doing? Is it passing an untyped array list? No, it's passing an array list that's been typed, inferred to be the upper bound we declared a query item. And that's what we get back, and why I've got an error on the call to print more lists. I can see that if I hover over the students 2021 variable. What I haven't done is call this method with an explicit type argument, or a type that can be inferred. When the type can't be inferred, I can specify the type argument before the method invocation, after the class name and dot there. I'll add student in angle brackets before the method call, but after the dot. This is saying the new list that will get created in the getMatches method will be a list of students now. This is a bit of a contrived example, but I wanted to show you how you'd specify a type argument for a generic method that's also a static method on a class. In most cases, the type can be inferred by the argument being passed. I'll revert those last two changes. Let's go back and look at that generic class, queryList again. I want to reiterate that the type on that generic method is not the same type as the class itself. In fact, let's change the type on the method to S in all cases. You can see that the code compiles and works as before, so even though our generic class doesn't have an S type, it doesn't matter. A generic method's type is unrelated to the type declared on the generic class. Now let's say we really only want this queryList class to work for students and subtypes of students, as well as only those types that implement the query item interface. We can do this by specifying multiple upper bounds. Let me do that, then I'll talk about a few rules for this. Here, I'm saying that any type that uses this class must be a student or subtype of the student class, and it also must implement the query item interface. You can use multiple types to set a more restrictive upper bound with the use of an ampersand between types. The conditions require a type argument to implement all interfaces declared and to be a subtype of any class specified. You can extend only one class at most and 0 to many interfaces. You use extends for either a class or an interface or both. If you do extend a class as well as an interface or two, the class must be the first type listed. Notice what happens if I add another interface at the start of this upper bound expression. I'll add comparable. You can see I've got an error on student by doing this. I get the message interface expected here. This is the same as saying student because it's a class must come first. I'll revert that last change and leave the upper bound as student and query item. Let me create a record in the main.java source to test this restriction. I will call it employee, record employee with a field of type string called name, and it will implement query item. I'll just leave the default implementation because we're really not interested in this record as much as we are in the query list class. I'll go to the end of the main method and try to use the query list class with this new record. Query list of employee list equals new query list diamond operator. And you can see IntelliJ flagging that dev.lpa.employee is not within its bound and that it should extend student as well. Employee implemented query item, one of the conditions for the upper bound, but a type has to meet all the conditions for it to be a valid type. This means employee is not a subtype of student, so it's not a valid type argument for our query list. I will just comment that line out. Okay, so that's the end of our more advanced generics topics video. Don't worry if this was a lot to take in and you don't quite get it all. I'll be using examples in future code and reiterating as many of these points as I can as we continue to build on what we've learned in each section. In the next video, I have a challenge for you. It's going to start with the query list we created here and also use the student and LPA student classes.